We're going to have a program tonight that is quite unusual because it has to deal with a color that hasn't been seen in America before. It's called a lemon color, and Drew Lobenstein deserves the credit for developing that color. For those of you that don't know Drew, he's been a pigeon fancier for probably close to 50 years.
What's he look like?
Here he comes, right there.
Looks like that guy.
He is another of the teaching fraternity that includes Lane Gardner, John Ebner, Bob, Fred Maypod, and Wyrick. I don't know how many more. He's a speech teacher at Lambert Park College and is taught at the high school level and the college level. And he is a lover of Jacobins and fantails. He is going to be recorded tonight.
He says to look me in the eye, and he says, "There is no such thing as a brown Jacobin. Brown doesn't exist in Jacobins." And I got my lesson there at 13 years old. The old guy was, lived with his little goatee, and he was Mr. Expert on everything. But if he were alive today, I would look George in the eye and I would say, yes, there are brown Jacobins. I made them. I made them from scratch with the help of my friend Fred Maypod and his Norwich croppers. And so brown does exist in Jacobins today through the process of genetic, what call it, you get your food where you genetically alter it. But we also play games with pigeons, and we can genetically alter some pigeons. Now I have a bird in my hand that's one of about 12 genetic projects that I've worked on over the past several years. I'm thinking, all right, 1975, maybe that's not several years, but the first project I did was Andalusian Jacobins. And the pigeon that I began with was a half clean lake tumbler, half Chinese owl that was given to me by Bill Hawkinson. Names are coming fast and furious, and then if you remember Bill Hawkinson, you remember Adair Allen. And Adair Allen was the one that produced the Andalusian long-faced clean lake tumblers. Now I look in the faces going, yeah, I remember Adair Allen. But from that project that Adair began years and years ago, adding Andalusian, the color, to long-faced clean lake tumblers, and then having the quality come so good that he compete with them and win at shows with birds that he created from scratch, was a challenge that really probably hasn't been done by very many people. But I like to say I'm working on that. The bird I have in my hands here is what it says, a brown fade Jacobin. But this pigeon is the result of a genetic project that I've been working on for about 12 years. This pigeon was the reserve to the grand champion of the show at the pageant of pigeons last year. This is a bird that started as something else. It began as a homing pigeon. It began as a homer. And the color on this pigeon is fade. This is a faded pigeon. If you know what fade is, and you know about auto-sexing kings, for instance, auto-sexing pioneers, they come from a genetic character that's related to almond and qualmond. Fade is the third part down. But this pigeon, through the process of selective breeding, based on that knowledge of genetics, and thanks to Charles Darwin we have some, but also thanks to the guys that hung out with the Southern California Genetics Group for years at Joe Frazier's home, we had a great inspirational kind of opportunity to create things that never existed before. I have in my hands the reserve to the grand champion from last year's pageant of pigeons. This is a pigeon I made from scratch, from something else, racing homer, and then put it into Jacobins, selected the Jacobin quality, but kept the color on the formation. This happens to be a brown fade and grizzle. But it was good enough Jacobin type that Doug Boylan selected it out of 127 other Jacobins to be the second best bird in the show. That's where I would begin today, in that many of us, if you have the inspiration to do genetic work, and it has to come from something that you think can be done. And it started here because I thought it could be done. And I see the vision in my head. And some of you will think, why are you wasting your time with all of that? I catch that all the time. Well, when you get them up to standard, why, let me know and I'll raise them. I'm thinking, yeah, okay, I'm going to put in 10 or 15 years getting it ready, and then I'm going to give you birds that are already, put yourself into it and invest your time. But here's the deal. I have started with something that was pretty amazing for me. I know it's in here. about 12 to 15 years ago.
Don't move.
If you know about Charles Darwin's work, you know that he had some theories basically that are common to us today. You know about evolution, which he talked about, and that the pigeon, or the common pigeons today, are the result of evolution, that you've evolved from one form into another by selective breeding. Selective breeding was the other concept that he got out there. One of his big theories, was that if you select for a particular trait and you combine those by the birds you make into, selecting that particular quality characteristic, you can produce more of the same. There was another theory after the evolution called mutation. And one of those mutations happens that can oftentimes produce evolution, change it from one form into another. Things evolve, they mutate into some form that didn't exist before that can then be transferred to the young ones. Sometimes it's an advantage, sometimes it's not an advantage. Sometimes it's neither one. It makes no difference at all. But this mutation, this is a bird that looks like a racing homer, and it actually is my Generation 4 Egyptian swift. But the bird that I began with looked just like this. It was a lemon racing homer. Now what lemon is what they call extreme dilute. You have intense, you're going to have pale, which comes down a degree less. You have dilute, and then there's a fourth level of intensity of color called extreme dilute. This mutated about 12 years ago. Extreme dilute did not occur in pigeons until a fellow by the name of Jack Barkle discovered it in South Africa. Neat story that goes with this, Jack Barkle is from eastern Romania. Beatrice Atwood, who just willed me, actually she left me her house. If you guys remember Brad Atwood or Eddie Atwood, my birds have been at the house there for about the last 10 years. Brad passed away in 1992. But Beatrice Atwood's mother's maiden name was Barkle. And her family had come from eastern Romania. So Ann Barkle's daughter, Bee, invited me to keep my pigeons there in the backyard. Now I talked to Jack Barkle, who is from eastern Romania, who discovered the lemon mutation in South African racing homers. So here I am working with Barkle's lemon racing homers at the home of the daughter of Ann Barkle, both of them from the same location, from eastern Romania. I'd always found that was kind of an interesting little bit of history and small world attached. But this is what the lemon looked like. This is an Egyptian swift, but imagine a racing homer that looked like this coming out of normal blue racing pigeons. Blue bar and blue check. And this is what it looked like. And Barkle knew it was different, and he knew that the mutated thing, and he discovered after a period of time that it was sex-linked and recessive. Sex-linked and recessive. So it works like brown, works like dilute, works like, if you guys have ever raised reduced pigeons, that also is a sex-linked recessive trait. But this is a blue pigeon. This is a blue-based pigeon. This bird is basically a kite, blue-black. If you see those pigeons with the bronze necks and the dark blue or black wings, those are what the swifts look like that produce this one, with the extra genetic character called lemon or extreme dilute. I began with this. I began with this pigeon, and I started mating it to, first off, Jacobin pigeons and fantail pigeons, and then west of England, and then archangels. And so from the first racing pigeon, which has no feather characteristics at all, it looks normal. This is your 10 flights, 10, 12 tail feathers, normal looking pigeon, and in this case the Egyptian swift has about 2.5 more inches of feather on it. But imagine the racing homer that began like this, about 12 to 14 years ago. The bar pattern of this extreme dilute on blue looks like this. This is an extreme dilute blue pigeon. Look at this, is that pretty? I saw this in the picture and I went nuts. I said, wouldn't Jacobins look pretty that way? Or wouldn't fantails look neat if you could do that? Like, and I lost sleep several nights just thinking about it and staring at the photograph and trying to figure out how the hell am I going to get one of those? I want one. Then an ad came that they were available in Missouri. A fellow by the name of Charlie Clips was Barkle's representative here in the United States. It was doing the Barkle Racing Station here in Missouri of the United States. And I thought, well, how much are they? Well, the first one was $200 for the first cull I got, and $100 for a bird that was split. And I saved up, and I went nuts, not letting anybody know I was doing that. But I bought the first two, and I made it to fantails. And you would know that after several years of mating fantail to fantail, keeping track of the extreme dilute, and keeping track of the fantail quality and fantail feathers and the like, that it only took 6 generations to do this from racing pigeon. This is a standard fantail. 6 years of selective breeding under Charles Darwin's guidance, I guess. But knowing how this works and then being able to take the other characters from the breed along with it and then keep the color and add generation at a time that ingredient which brings the fantail back into view, I was able to do this. Now, at Oklahoma, the Gran National Pigeon Show last January, this bird was shown, and she was the best rare color or best new color or non-recognized color in the entire show against all fantails, all comers. So she was the first place at trophy winner against other fantails that have been pure for 1,000 years. But this one is created from racing pigeon, and she's got 7 years of fantail in her and generations of racing homer, but that lemon or extreme dilute thing is there. I also raised first or second cross with my fantail, and it sort of looked like a swan, and I was thanking Dan Skiles for some help. And so in a couple years, it only took about 3.5 years to do this and produce a lemon Indian fantail. We got a crest on the other ones that are home sitting on eggs, but this is three tries. And Indian fantails came pretty easy, but that's an Indian fantail.
What did you cross to make that Indian fantail?
Racing homer to Indian fantail. Actually, generation 2 cross for lemon standard fantail. So in some period of time, I got birds from Doug Boylan that were pretty decent quality west of England. And so I made that lemon racing pigeon into the west of England, and in 7 years I produced this. If you guys know about west of England, you know this is going to be competitive. This is a competitive west of England. Look at the neck on this bird, look at the head, and look at the tame. This bird sits on my hand. Partly because that's what I do, is I handle them a lot, but there's other stuff besides this lemon stuff that comes into the genetics, and the wonderful disposition, the calm, tame attitude. That's also a genetic characteristic that you can breed for or select for. There are a couple of other samples of this lemon. I've got them west of England here. I brought in another sample, but this is the kite version of west of England. This is extreme dilute of kite. And this one is extreme dilute of recessive red. And you can just look at the difference in these two birds, but this beautiful soft gold color. The difference is that the genetics here, this one is a kite, and this is extreme dilute of kite. And you look at this beautiful soft pastel gold yellow bird, this is extreme dilute of recessive red. Now I have recessive of black, extreme dilute of black. I'll show you what that looks like on a Jacobin. I have them in west of England, but I didn't bring that bird because it's sitting on babies that just hatched.